Hi everyone, in this video there's gonna be 4 sections. The number 1 is what is an inscribed angle. The number 2 is what is intercepted arc. The number 3 is example number 1. And the 4 is theorems of an inscribed angle. So now the first thing that we should do is we need to define first what is an inscribed angle. So when we say inscribed angles, it is an angle whose vertex is on the circle and whose sides contains chords of the circle. And then the second one is intercepted arc. So when we say intercepted arc, it is an arc that lies in the interior of an inscribed angle and has endpoints on the angle. So now we're done with defining the two, which is the inscribed angle and intercepted arc. So let's move on now to the example number 1. In this example number 1, I will show you how to get or define the value of an inscribed angle based on its intercepted arc. So here is now the illustration of the example number 1. So a circle is centered in a point A, which is right over here, and then point Z and Y is our inscribed angle here that we are finding is lie on its circumference, and then the measure of its intercepted arc is 160, which is here, arc ZY, so that we will be finding now the value of our inscribed angle. So let's find out. So now we are here in the last section, which is the theorems of an inscribed angle, and according to this, it consists of 4 theorems. And then the first one is, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. And then the example of this is my example before, which is here. So let's find out here. So here is now the solution. So angle Z and Y equal 1/2 times measure of ZY, which is the arc, is equal to 1/2 times substitute the measure of the ZY, which is 160 right over here. So now 1/2 is the constant based on the theorems number 1. So 1/2 times 160 is equal to 80, which is 80 degrees, which is the value now of our inscribed angle Z and Y right over here. Okay, so let's move on now to the example number 2. But before that, let's move on now to the the theorems number 2. So theorems number 2. If two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So it tells that if the two inscribed angles of a circle are congruent and they are the same arc, then the angles also are congruent, just like this example. If the measure of angle NIC is equal to 38 degrees, therefore the measure also of angle KEL is 38, because they are congruent arcs, or they are intercept the same arc, right? So let's move on now to the theorem number 3, which is, if an inscribed angle of a circle intercept a semicircle, then the angle is right angle. So when the third theorem in the semicircle, the intercept arc measures 180 degrees, and therefore any corresponding inscribed angle would measure half of it too, because the measure of a whole circle is, since 360 means the the semicircles measure 180 degrees, so that the angle here is right angle, which is measure of 90 degrees. So now let's move on now to the last theorem, which is the number 4. If a quadrilateral is inscribed in a circle, then its possible angles are supplementary. So here is now the example of theorem number 4, which is the supplementary. If see here, quadrilateral PEAC is inscribed to circle H. The angle of EPC plus measure of EAC is equal 180, and then the measure of PEA plus measure of PCA is 180 degrees, which means 360, which is called supplementary. And that's all about the arcs and inscribed angles. And thank you for watching.